All right? So that's what it is, but still I haven't made any progress in figuring out any better how I drew that line. So I have to say something that's more concrete because I want to be able to cook up what these numbers are. I have to figure out what this number m is. And one way of thinking about that, let me just try it, is, so I certainly am taking for granted that in the sort of non-calculus part that I know what a line through a point is. So I know this equation. But another possibility might be, this line here. How do I know? Well, unfortunately, I didn't draw it quite straight, but there it is. How do I know that this orange line is not a tangent line, but this other line is a tangent line? Well, it's actually not so obvious, but I'm going to describe it a little bit. It's not really the fact this thing crosses at some other place, which is this point Q, but it's not really the fact that the thing crosses at two places, because the line could be wiggly, the curve could be wiggly, and it could cross back and forth a number of times. That's not what distinguishes the tangent line. So I'm going to have to somehow grasp this, and I first do it in language. And it's the following idea. It's that if you take this orange line, which is called a secant line, and you think of the Q, the point Q is getting closer and closer to P, then the slope of that line will get closer and closer to the slope of the red line. And if we draw it close enough, then that's going to be the correct line. So that's really what I did sort of in my brain when I drew that first line. And so that's the way I'm going to articulate it first now. So the tangent line is equal to the limit of what so-called secant lines, PQ, as Q tends to P. And here we're thinking of P as being fixed and Q as varying. All right, so that's again, this is still a geometric discussion, but now we're going to be able to put symbols and formulas to this computation, and we'll be able to work out formulas in any example.